Your team changes SIEMs. Monday morning, the detection backlog explodes. 400 working rules now speak the wrong language. The use cases are still valid. Suspicious sign-ins, weird admin activity, PowerShell abuse. But every query needs a rewrite before it can run. That is where Sigma rules matter. They give defenders a shared way to describe log detections, so the rule survives the platform change. Write the detection logic once. Convert it into the SIEM query language you need. Sigma is a vendor-neutral rule format for log detections. Plain English version, it is a YAML file that says, when logs look like this, raise this detection. A converter then turns that YAML into the query language your SIEM understands. Think of Sigma as a portable detection specification. In NIST-style terms, it supports the detect function by standardizing analytics for events and logs. A beginner should remember this. Sigma is not a SIEM. It is not a log collector. It is a way to write detection logic once and translate it. Sigma is to logs what Yara is to files, a common language analysts can share, review, and reuse. Before Sigma, every SIEM rule library was tied to one query language and one field model. That creates pain in three places. First, migration. Moving platforms turns good detections into a rewrite project. Second, collaboration. Another team may share a smart rule, but if it is written for a different query language, your team still has work to do. Third, consistency. The same detection can be rewritten 5 different ways, with small logic changes that create different results. Sigma reduces that friction. It gives the detection engineer a clean source format. The SIEM dialect becomes an output step, not the place where the idea is trapped. A Sigma rule has a simple shape. The log source tells the converter where the rule applies. For example, process creation events from an operating system. The detection block lists fields and values to match. That might be a process name, command line content, event ID, username, or parent process. The condition tells Sigma how to combine those selections. For example, selection 1 and selection 2. That is the core: log source, detection, condition. Metadata helps humans manage the rule, but those 3 parts carry the logic. Then a converter reads the YAML and outputs the target query syntax. The converter handles the dialect, pipes, operators, quoting, case handling, and the target query shape. Here is the SOC story. An analyst wants a portable detection for suspicious PowerShell command line flags. The Sigma rule starts with log source, operating system process creation. In detection, selection 1 matches the process image ending in PowerShell. Selection 2 matches command line fragments often seen in risky activity, such as encoded command, hidden window, or no profile flags. The condition is simple: selection process and selection flags. Save that as YAML. Now run the converter for your SIEM target. Out comes a native query using that SIEM search syntax. The analyst loads it into a test workspace, runs it over 7 days of process logs, reviews hits, and adds safe internal automation to an exclusion list if needed. Sigma's strength is portability. It helps teams keep detections separate from SIEM syntax. It also makes peer review easier because the logic is readable YAML. The community repository is another major win. Thousands of free rules cover common behaviors, tools, and log sources. But Sigma does not make bad logs good. If your endpoint logs do not capture command lines, a command line rule cannot work. Sigma also does not guarantee low false positives. You still test and tune. The biggest caveat is field name mapping. One environment may call the field command line. Another may store the same data under process.command line. If the mapping is wrong, the converted query can miss events or return junk. Sigma fits in the detection engineering layer between the idea and the SIEM rule. It does not replace log collection, endpoint visibility, enrichment, case management, or analyst judgment. A good flow looks like this: identify a behavior worth detecting, write or adapt a Sigma rule, convert it, test it in the SIEM, tune it, then manage it like code. UEBA can still add value by spotting unusual behavior over baselines. Sigma rules usually express known patterns more directly. In practice, both help. A Sigma alert might say a process used suspicious flags. A UEBA alert might say the user behavior is unusual. Together, they give the analyst better context. Start small. Pick one log source, such as process creation, authentication, or DNS. Read 20 well-written community Sigma rules for that source. Notice how they use titles, descriptions, log source, detection selections, and conditions. Then, build a field mapping for your environment. This is not glamorous, but it decides whether conversion works. Take one rule, convert it, and run it as a hunting query before making it an alert. Measure volume, review real matches, add clear comments for any local tuning. Skills to learn: YAML basics, your SIEM query language, your log schema, and basic detection testing. Treat Sigma content like code. Version it, review it, and document changes. Recap in 3 beats. 1. Sigma rules are portable YAML detections for log events. The core is log source, detection, and condition. 2. Converters turn that shared logic into the query dialect your SIEM speaks, which makes migrations and rule sharing much cleaner. 3. Field name mapping is where many teams stumble, so test conversions against real logs before you alert. If you remember one line, remember this. Sigma is to logs what Yara is to files. It gives defenders a common language. Subscribe for a new Security Tools Decoded episode every day. And if you track vulnerabilities, watch the daily ranked CVE brief on this channel.